All right, everybody should have their lesson 8.5 notes out in front of them. Today we're going to be talking about systems of linear inequalities. So just to start, we're going to start with just a single linear inequality and just do a quick review of how to graph this. So for starters, when it's in standard form like this, we want to first transform that into slope-intercept form. So I'm going to begin by subtracting x from both sides, which is going to leave us with negative y greater than or equal to negative x plus 2. So to get this y by itself, we need to think about either multiplying or dividing by a negative 1, which is going to change all of our signs here. And keep in mind that when we do that, I always like to circle the inequality. We are going to need to flip that. So this is actually going to become y is less than or equal to positive x minus 2. So we're going to go ahead and plot this on our graph just like we would any other line, starting with our y-intercept at negative 2, and we've got a slope of 1. So we're going to count that up. Give yourself a few clear points here. Probably best to have a straight edge out with you and during homework, quiz, and test. Now before we connect these dots, I want you to make a quick note for yourselves. When we are graphing inequalities, we have two options. We have strictly less than or strictly greater than. And the other option is we have less than or equal to, or we have greater than or equal to. When it is strictly less than or strictly greater than, that is when we want to have a dotted or dashed line. Down here, when it's less than or equal to, greater than or equal to, this is when we get to have a solid line. And that's one of those things that you want to be paying attention to and thinking about the whole time. So we are going to go ahead and graph this line. It needs to be solid in this case. And I'm going to use this little tool that's not working. All right. Not going to work with me. So you guys get the idea here. There we go. I'm just going to draw this in. Excuse my crooked line. So now the next part of this is to decide where we want to shade. And I want you to think about picking a test point. Plug it in. It doesn't need to be a ton of work. But we are looking for whether or not we get a true or false statement. So the easiest test point for us to use is always going to be the origin. Unless your graph passes through the origin, in which case you're not going to be able to use it, try and stick with 0, 0. So if I plug 0, 0 into my new inequality, I get 0 is less than or equal to 0 minus 2, which means 0 is less than or equal to negative 2. So then you're asking yourself, is this a true statement or a false statement? In this case, it is false. 0 is not less than or equal to negative 2. So what that means for us, if it's a false statement, we want to shade the side of the line away from that point. So in the area that does not contain 0, 0. So in this case, that's going to be everything below the line. Yours will be a lot nicer than the way mine looks right now. But as long as it's clear to me which side of the line you are shading, I'm happy. Keep in mind that if we had instead plugged our test point 0, 0 into the original inequality up here, x minus y greater than or equal to 2, you should still get the same result. So in this case, I have 0 is greater than or equal to positive 2, which is still false. So we've got double verification here that we should be shading below the line. So, next up, we are going to transition now into multiple graphs on the same axes, and the end goal here is to figure out where the overlap is. I need you to make sure that your solution set, what you want to be the solution set, is darker than all of the rest. So sometimes students will use multiple colors, sometimes they'll draw lines, and wherever it's crisscrossed and makes a plaid pattern, that's where the solution is. As long as I can tell, I'm happy. So this first example, both of these lines are already in slope-intercept form, which is pretty nice for us. If you notice, the first inequality is greater than or equal to, that should be a solid line. The bottom one is strictly less than, that's going to be our dotted or dashed line. So let's start with the solid line. I'm going to plot my y-intercept at -1, and this time I have a slope of -3. So I'm going to go up 3, left 1. And moving down 3, right 1. And I'm not going to mess with the line function, so please excuse my crooked line. Yeah, that did not work. Let's try that again. There we go, close enough. And I know it's hard to tell here, but what I want you to notice is that 0, 0 is very distinctly above the line. So now I'm going to go through and plot this dotted line, positive slope, and a y-intercept of +2. So this is just a slope of 1, nice easy line. And then moving back in the other direction. Here we go. So now, when you draw this, and this is something you need to be paying attention to, we actually want this to be a dotted line. All right, so now for the test points. Both of these we can use 0, 0 again. And like I said in the first example, I don't need to see a ton of work for this, but just show me plugging in 0 to this first inequality. I think we can all agree that this -3 times 0 goes away. And I'm left with the statement that 0 is greater than or equal to -1. This is true, which means I want to shade the side of the line that contains 0, 0. This is my solid line, so I'm actually going to change the color here. And I'm just going to do some stripes here. I'm going to show that I would be shading everything to the right and above this solid line. So then moving on to the second inequality, same thing. I'm going to plug in 0 for y and 0 for x. I get that 0 is less than 2, which is also a true statement. So the side of this dashed line that contains 0, 0 is below it. So if I do that in green, I'm going to do the same thing. So sometimes using multiple colors helps us to see that solution set, but really what we should be looking at, and I'll do this, in blue, we can all see where it's red and green together. My solution set should actually be everything below the dashed line, but above the solid line. And as long as that is darker or completely filled in or circled and you tell me that that is your solution, you should be good to go and you will earn full points. Taking a look at example number 3, this top equation actually needs to be rearranged into slope-intercept form. So I'm going to do that up here, starting by subtracting x from both sides. So negative 2y is greater than or equal to negative x plus 4. We're going to go through and divide every single term by negative 2, which means, as a reminder to myself, I'm going to circle that inequality sign. I need to change the direction. So I end up with y is less than or equal to, here the negatives are going to cancel, so I'm left with positive 1/2 x minus 2. In this example, both of the lines are going to be solid, so we don't need to worry about switching between the two. I'm just going to go ahead and plot my y-intercept at negative 2. This one we're going up 1 over 2. And if I go down 1, I'm going to move to the left 2. All right. Now for our line, I'm going to go ahead and switch this back to a solid line. Nice flat slope here. All right. Our second inequality is already in slope-intercept form, but if you notice it has a negative slope. So I'm going to start at my y-intercept of positive 1. And let's go ahead and move down to right 1. Or if I move up to left 1. All right. One more line here. Perfect. All right. So, again, my line is a little bit off. This negative slope inequality that we just drew in has 0, 0 just below the line. So we can still use 0, 0 as a test point. I'm going to do a couple different colors again, starting with red. So it shouldn't matter if I plug my test point into the original inequality or my newly transformed inequality. If I plug it in here, 0 is less than or equal to 1/2 times 0, which goes away, minus 2. So I'm looking at 0 is less than or equal to negative 2. That is a false statement. So for this bottom line with my positive slope, I want to shade the side of the line that does not contain 0, 0, which is everything here below the line. When I do the same thing with my second inequality, I'll do that up here since it's already in slope-intercept form for me. That goes away. I get that 0 is less than or equal to 1. That is a true statement, which means I need to shade to the left and below this line. Remember that even though it's hard to see on my graph, 0, 0 is actually just below the line since I have a y-intercept at positive 1. So what that means for me is my solution set, my final answer that I'm going to shade in darker, is everything down here at the very bottom of my axis. All right. The next problem we're going to take a look at, so if you turn your notes over to the next page, example number 4, I wanted to go over one of these because you will see something like this on your homework worksheet. So this is actually an absolute value graph as opposed to just a linear inequality. And I want you to understand that nothing changes about this other than we're going to apply our transformations of functions to that absolute value. So because this -2 is out of the house, that means I have my normal absolute value graph shifted down 2. And something that's important to note here is that even though it's an absolute value, it's going to be made up of dashed lines. Dashed or dotted. So I'm going to take my vertex of my absolute value. It is at -2, and remember, it just has a slope of +1 on the right and a slope of -1 on the left. All right, so let's see if I can make this work. All right, so dashed on both sides, we should have a nice V shape here. And here's what I want you to be thinking about moving forward. The option when you have something other than a linear inequality, we are either going to be shading inside the absolute value, which we can all see contains 0, 0. That's going to be our test point. Or we would be shading everything outside of the absolute value. So those are your only 2 options when you have something other than a linear inequality. This second inequality is going to be a line. All I have to do is subtract that 2x. I don't need to worry about flipping the sign. And let's just go ahead and graph this one like normal. Slope of -2, so that means down 2, right 1. Got a little overlap there. And I can move up 2 and back. All right, let's get our line in. In this case, because it is less than or equal to, we want to go back to a solid line. Start that up here, drag it all the way down. All right, last piece is to use our test point. So let's go ahead and start with the absolute value to determine if we're shading inside or outside. If I plug in 0, 0, try that again. It still wants to graph a line. Okay. Erase that. Okay. So if I plug in 0, 0. All right, so if we plug in 0, 0 to this absolute value of 0 is just 0, I am left with 0 is greater than -2. That is a true statement, which means we should be shading inside the absolute value. So I'm just going to do some lines in here. I want everything inside my absolute value. Jumping over to our linear inequality, and again, remember, it does not matter if you plug it into the original inequality or your transformed inequality. I am going to end up with 0 is less than or equal to 4, which is also true 0, 0 is below this line, so I should be shading everything below. When I look for my area of overlap, where I see red and green, it needs to be inside the absolute value, but below the line. So it's kind of this weird quadrilateral type shape right in there. And that's going to be your final solution. All right. Example number 5, this is kind of working backwards from what we've been doing. This is giving us a shaded inequality and asking us to come up with the inequality that's represented by that particular graph. You will see a couple of these on your homework tonight. So first thing I want you to notice is that I have a line and it is dotted. So that means in terms of my symbols, I should be looking at strictly less than or strictly greater than. There should be no or equal to part involved. The next thing I want you to notice, since it is a line, I have a clear, distinct y-intercept at -3. So y-intercept is at 0, -3. And this one's pretty nice because we can just count the slope. We know it's a positive slope. I've gone up 1 over 1, 2, 3, 4. And if you just want to be sure, go up 1 again, to the right, 1, 2, 3, 4. So I know that my slope has to be a positive 1/4. So what I like to do here is kind of leave an empty box. Rather than writing y equals mx plus b, I'm going to do y and then this empty box with a 1/4 x minus 3. What we have to think is my test point, 0, 0, that is in the area of the line that's been shaded, which means I am looking for a true statement. So if I plug in 0 for y and 0 for x, I want a statement that's going to be true here, 0 compared to -3. If I want a true statement, 0 has to be greater than -3. So I'm just going to come back up here, I'm going to fill in that empty box, and this right here is going to be my final inequality. All right, last 2 questions we're going to take a look at. The inequalities look a little bit scarier, but they're really a little bit nicer. So let's take a look at number 6 here. We see 1 is less than or equal to x is less than or equal to 3. Think about just looking at part of this at a time. So if I covered up the 1, I'm looking at the statement that x is less than or equal to 3. If I cover up the 3, I see that x is greater than or equal to 1. These translate into vertical lines, kind of like our vertical asymptotes that we talked about back in chapter 3. So all I need to do is I need to find 1 on the x-axis and 3 on the x-axis. Both of these are going to be solid lines. So let me jump back over to my line here. And I am going to draw a vertical line straight through 1, and then same thing, straight through 3. So the nice thing about this is I don't really need to do any test points here because this shows me that x has to be everything between 1 and 3, which means I would actually be shading everything between those 2 vertical lines. So then we can move on to our bottom inequality. To start, this says y is greater than or equal to 0. That is the x-axis. So I know that everywhere that I'm shading needs to be above the x-axis. So I'm just going to quickly draw in another solid line right along the x-axis, and I know that I'm shading everything above that. So really, we only have one linear inequality that we kind of have to think about and do a test point for, and that is y is less than or equal to x plus 2. Same thing we've been practicing. I'm going to start at 2, slope of 1. And we're going to see those nice intersection points. And if I draw in my line, everything here is going to be solid. That is what I am left with. So the second part of this is asking us to find the coordinates of the corner points of the graph after we've finished shading. So we already said that we're shading in between the vertical lines, above the x-axis, and if I throw a test point in to this last inequality, 0 is less than or equal to 2, I get another true statement, which means I should be shading below the line. So if I'm looking for my solution set in between the two vertical lines, above the x-axis, and below the line we just drew in, this is it right here. This actually forms a little trapezoid, and that's why part B is asking us to find the coordinates of those corner points. So I've got two x-intercepts here. So my first corner point I'm going to list as 1, 0. My second corner point is over here at 3, 0. And then I'm going to have two more intersections with this line that I drew in. One is going to have an x value of 1. And remember, we started at 2 and we went up 1 over 1, so that output is 3. And then my last intersection is when x is 3, and my output, we can see, is up here at 5. That is going to be useful to us next week when we start what's called linear programming, and we're trying to find boundary points for a solution set. So we're going to practice one more of these, and then you can get started on your homework. So with number 7, we've got, this is kind of interesting here, 2 vertical lines. And then the next piece that we're given is going to be 2 horizontal lines. And again, these should be really quick and easy for you to graph. This, we're shading everything between 1 and 6. And for these horizontal lines, we're shading everything between 2 and 5. So let's get some lines going on our graph. Everything here again is going to be solid. So I need a vertical line. That did not work. Let's undo that. I need a vertical line, there we go, at 1. And then another one over here at 6. And then while we're at it, let's go ahead and plug in our horizontal lines. One is here at 2. And my next one is at 5. So far what we've made, shading between the 2 vertical lines and between the 2 horizontal, is this nice little rectangle. And I've got one more thing that I need to graph. There's going to be a line that cuts through this rectangle and gives us our solution set. So in this case, I need to subtract x and divide by 2. So I'm going to end up with y is less than or equal to negative 1/2 x plus 7. So here's my y-intercept of 7, slope of negative 1/2. So I'm down 1 over 2. And let's go up 1 over 2 just to get another point in there. Another solid line. All right, so far we know we are in this little rectangle here. So the question is, Do I want to be above the green line that I just drew in this little teeny tiny triangle, or do I want to be below it but inside of this box still? So if I test 0, 0, I end up with 0 is less than or equal to 7, because that term goes away, which is true, and that tells me I actually want to shade below the line because 0, 0 is contained below it. So I have to stay within my little rectangle, but now I want to be below the green line. So my solution set should be this area right in here. And then the last piece of this, again, is to identify those corner points, and that's where we're going to end today. So first intersection happens right here when x is 1 and y is 2. Then I've got another intersection when x is 1, but this time y is 5. Let's move over to this one here because it's a little bit clearer to see. That's when x is 6 and y is 2. And then I've got 2 more boundary points here. So the first one, remember we started at 7 and we went down 1 over 2, down 1 over 2. So that's going to put me at an x value of 4 and a y value of 5. And if I come down 1 and over 2 again, that's an x value of 6 with a y value of 4. All right, so at this point we are done with the notes. Thank you for being so patient with me during this video. And now would be an appropriate time for you to go grab the homework worksheet from the sub and you can get started on your homework.